Okay, class, today we're in section 5.7, graph linear inequalities in two variables. Before, you graphed linear equations in two variables. Now, you will graph linear inequalities in two variables. Why? So you can analyze a music competition as in exercise 56. Key vocabulary: linear inequalities in two variables, graph of an inequality in two variables. A linear inequality in two variables, such as x minus 3y is less than 6, is the result of replacing the equal sign in a linear equation with less than or equal to, greater than, or greater than or equal to. A solution of an inequality in two variables, x and y, is an ordered pair, x and y, that produces a true statement when the values of x and y are substituted into the inequality. Example 1. Standardized test practice. Which ordered pair is not a solution of x minus 3y is less than or equal to 6? A, 0, 0, B, 6, negative 1, C, 10, 3, D, negative 1, 2. Solution. Check whether each ordered pair is a solution of the inequality. Write the inequality, and then next we're going to test 0, 0. That's our first pair to test. So where x is, I put 0. Where y is, I put y. Excuse me, where y is, I put 0. Alright, so now I have 0 minus 3 times 0 is less than or equal to 6. 3 times 0 is 0, and 0 minus 0 is equal to 0. So 0 is less than or equal to 6. That turns out to be true. Next, I test what's in line next. Next, I have 6 and negative 1. So testing 6 and negative 1. Where x is, I put 6. Where y is, I put a negative 1. Follow my order of operations, I will do my multiplication first. A negative 3 times a negative 1 is 3. 6 plus 3 is 9. So once again, there should be 6 plus 3, because a negative times a negative is a positive. So 6 plus 3 is 9. I end up with 9 is less than or equal to 6. This is not true. So 0, 0 is a solution of x minus 3y is less than 6, but 6 and negative 1 is not a solution. Graph of an inequality. In a coordinate plane, the graph of an inequality in two variables is the set of points that represent all solutions of the inequality. The boundary line of a linear inequality divides the coordinate plane into two halves. Only one half plane contains the points that represent the solutions of the inequality. Key concept: graphing a linear inequality in two variables. Step 1. Graph the boundary line. Use a dashed line for less than or greater than, and use a solid line for less than or equal to, or greater than or equal to. Step 2. Test a point not on the boundary line by checking whether the ordered pair is a solution of the inequality. Step 3. Shade the half plane containing the point if the ordered pair is a solution of the inequality. Shade the other half plane if the ordered pair is not a solution. Example 2. Graph a linear inequality in two variables. Graph the inequality y is greater than 4x minus 3. Now, you can't graph the inequality if you don't know how to graph in slope-intercept form. Here, we're going to give you a quick review as we do the problem. The slope is 4 over 1, and the y-intercept is a negative 3. You graph the y-intercept first, negative 3. I'll go right here, and right there is my negative 3. Then I'm going to count my slope, which is 4 over 1. Rise over the run. Rise over the run. So I get 1, 2, 3, 4. Then I go over 1. Right? That gives me enough information to draw my line. So now I have my line. I notice that it says greater than without the equal sign, so that means my boundary line will be dashed, not solid, just dots, dashed, not solid. Now, since it says greater than, that tells me to shade above the line. So here, I'm shading in this direction. All this right here must be shaded. That means everything in this region that is blue is a solution except what's on the dashed line. Anything on the line is not a solution. If the line was solid, it would be a solution. Okay, now to help some people out who may be confused on how to shade, it's pretty simple. If my line is slanting in a positive direction, this is a positive direction, then greater than would be above the line, like so. Be all of that right there. All right. If my line is going in a negative direction, then greater than would be above the line, like so. Okay. If my line was horizontal, greater than would be above. And if my line was vertical, greater than would be on the positive side. All right. Greater than would be on the positive side. Okay. Now, less than would be for a positive line. Less than would be below. For negative, less than, this is below. For horizontal, less than, this is below. And for vertical, less than, of course, is on the negative side. Example 3. Graph a linear inequality in two variables. Graph the inequality x plus 2y is less than or equal to 0. Well, we can't graph this equation until we put it into y equals mx plus b form. To do that, once again, this is a review. We should already know this, but we want to help out those who may be stuck. X plus 2y is less than or equal to 0. I'm trying to get the y by itself, so therefore I want to get rid of this x. I'm trying to get the y by itself, so I want to get rid of this x first. So it's a positive x right now, so I'm going to add a negative x to both sides. So I'm going to subtract x. Minus x, minus x. X minus x is 0, so I'm left with just 2y is less than or equal to 0 minus x. And that's going to give me a negative x or minus x. Once again, I'm trying to get the y by itself. I'm trying to get the y by itself. So to do that, I'm going to divide both sides by 2. Why? Because it says 2 times y. What's the inverse of multiplication? Division. So I divide both sides by 2 by 2. 2 here and 2 there. 2 divided by 2 gives me just the y by itself, because 2 divided by 2 is 1. So it already says 1y that I don't see. And then I divide this side also by 2. So I got a negative x or a negative 1x divided by 2. So my equation ends up being y is less than or equal to a negative x over 2. Now what's my slope and what's my y-intercept? My slope is a negative 1/2. Where did that 1 come from? Because there's a 1 in front of x. How many x's do you see? 1. So there's a 1 in front of it. Over 2. And what's my y-intercept? 0. There is no y-intercept there at all. Alright, so now I'm ready to graph. So I graph my intercept being 0. That's there right there. That's that point right there. And what's my slope? A negative 1 over 2. Don't forget, rise over run. So I got a negative 1. I go down 1. Then I go over 2. 1, 2. Down 1. Over 2. 1, 2. Down 1. Over 2. 1, 2. All right, and that gives me my line. Now notice it says that it is what? Less than or equal to. Less than or equal to. That means my line has to be solid because it says equal to. Now it says what? It says less than. Now because it says less than, that means I will shade below the line. Below the line. What that means is everything that is on this line is a solution, and everything below the line is a solution. So therefore, If I were to ask you if 0, 0 is a solution, you would say, if I were to ask you if this point is a solution, you would say, okay, and that concludes example 3. Linear inequalities in one variable. The steps for graphing a linear inequality in two variables can be used to graph a linear inequality in one variable in a coordinate plane. The boundary line for an inequality in one variable is either vertical or horizontal. When testing a point to determine which half plane to shade, do the following. If an inequality has only the variable x, substitute the x coordinate of the test point into the inequality. If an inequality has only the variable y, substitute the y coordinate of the test point into the inequality. Example 4. Graph a linear inequality in one variable. Graph the inequality y is greater than or equal to a -3. Alright, this should be pretty quick and it should be a review. Alright, y is greater than or equal to a -3. All that means is you go along the y-axis, locate -3, and then you make a horizontal line. Now it says equal to, so therefore the horizontal line should be solid. And then it says greater than, that means you shade above. Once again, every point that's on the line is a solution, and every point that's above the line is a solution. Example 5. Graph a linear inequality in one variable. Graph the inequality graph the inequality x is less than or equal to a -1. Once again, this should be a review. X is less than a -1. Alright, all we do is we go to the x-axis, we locate -1, and we make a vertical line. We make a vertical line. Now here the line is dotted or dashed. Why? Because it only says less than. And less than would be back in a negative direction. Like so. All of that is less than. Now, remember that the points on the dotted line are not a solution. But every point in this region and back is a solution. Any point. So here would be a solution, their solution, their solution, their solution, their solution. But on this line, anywhere, no solution, no solution, no solution, no solution, anywhere on the line. All right, that concludes your lesson for today. All right, you may get started.